Okay, so it'd be good to start with a little bit of background on Mapal as a company, bit of history and any of key milestones along the way to where we are today.
So thanks, Phil. Thanks for having me online on this vlog. So Mapal was founded in 2010 with an idea. And the idea really came around when the founders at that point in time saw a problem in the industry. And the problem we really came to solve was how to replace energy guzzling, really inefficient surface aerators with this new technology which had come around maybe 10 years before, which was fine bubble aeration. And why I say energy efficient and unsafe, well, I mean that from a health and safety perspective. So you have moving parts in the water, you have people which need to go into this effluent to go and treat them, and therefore unsafe from that perspective. But of course, energy guzzling, because the way that aeration really works is that the surface aerators churn up the water, and a lot of energy goes into the friction between the water and the aerator. Whereas this, let's call it this newer technology, which had come around maybe 10 years before that, was fine bubble, which was taking really the air to the water rather than the water by spraying it up to the air. So what they then said was, well, how do we replace these things? Now, because most surface aerators are sitting in lagoons, there is a problem of retrofitting fine bubble aeration because you need a concrete floor to that. So what Mapal came around to do was really to find a way to float, fine bubble, and hence our name FFB, Floating Fine Bubble Aeration Systems. And over time, we developed that into different products through R&D, and we have now what we call retrievable. So that's actually sitting on the surface, and we'll deal with that maybe a little bit later on. But really, an example of that is the picture sitting behind me. Those are retrievable systems. So they're in a concrete new reactor, but they actually sit on the floor and are like a fixed to the floor fine bubble, but retrievable. And maybe later on we'll deal with some of the benefits of retrievable first of that. Now, just going back, so we were founded in 2010. Our first sale of a very rudimentary system was around 2012. We then spent 2 or 3 years doing some serious R&D, and we then really started selling to the market. We've come a long way since then. We've done over 100 installations. I think we just did 110th installation in the past couple of weeks. At the moment in 9 different countries around the world, and we really have become to be a bespoke, let's call it solution to the wastewater industry.
Okay, and one of the reasons we're talking today is, I believe, you are in the middle of a crowdfunding round. I don't know if that's the correct expression, but and presumably that's to raise funds for some specific activities. So it'd be good to understand, I guess, first the amount you're hoping to crowdfund and what that investment money will be used for.
Correct. So over the years we've had a few different rounds of funding. And that most of that funding to date has gone into R&D and product development. We're a lean company. We don't have any excess big offices, big facilities. So we're really lean. We've rolled out there, and we now already have repeat customers. But in order to really now take it to the next level, I mean, we've done 5 projects in the UK, but very few people have heard of us. So what we now need to do is take it to the next level, and we're really raising money now in order to be able to spend on marketing. We need to get their marketing and sales, get out there, get our name known, and start and start pushing it more, because we are a solution. And when people hear about our solution, they're very excited about it. But we really need to get out there for. So the round is really designed for to give us money to do that. We chose crowdfunding because one of the reasons was that we wanted to broaden our shareholder base somewhat. We wanted to bring in new funders. We have a group of funders who've been funding us over and over for the past let's call it 10 years. and we wanted to broaden the base. Those shareholders from before have supported us in this round, so they formed the core, the core equity raise needed to do crowdfunding. And now we're really going out to the crowd, and I think it's been it's been quite enlightening and quite positive. It's assisted us in focusing our message. It's assisted us in some of the very good questions which have come out in the discussion groups. And so far, we can say the first week of crowdfunding has been a success, and we hope to build on that and get our target. Our target, let's call it our first target, is £400,000, to which, as of this morning, we're sitting on about £345,000 from 160 odd unique investors. And we hope to get to our 400,000 and hopefully beyond that. And to those people interested in investing and those there, the money is going primarily into marketing and sales, which will increase our, obviously there to increase our turnover, increase our profitability.
And just quickly before we move on to the technology itself, you said, I think you've carried out 5 installations in the UK. So do you have an agent there? Do you have an office? What presence do you currently have in the UK, and what do you hope to, I guess, develop?
So we have an office in the UK, and we have a partner. Our partners in the UK on North Avon Water Solutions. North Avon, we've been partners with them for about a year. However, all our installations that we've done to date, which were 4 municipal and 1 industrial, were actually predating that. We've done a project for Horwich Water, Chesham Water, Thames Water, and Stanford Bridge, and we did an industrial solution for McCain's, the food manufacturers. We came to solve a very specific problem that they have, and we provided an emergency oxygen, what we call an emergency solution to them, to install units to augment their oxygen requirements for their wastewater reactor.
Okay, so onto the technology itself, and its floating and retrievable fine bubble aeration systems is the sweet spot. So if you can perhaps talk us through a little bit, you've already covered it slightly, but talk us through the technology itself, any particular USPs, and for listeners, one of the important things, I guess, is the benefits that your approach to aeration delivers.
Sure. So, I think one of the things, and you're right, I did allude to it earlier, is that we're able to, why do people, let's maybe touch on this. Why do people need oxygen in wastewater to start off with? Well, they need oxygen because the oxygen in the water is the heart of the biological process, right? The oxygen feeds the good bacteria, eat the bad bacteria, and hey presto, you meet what's called the effluent consent, the requirement from the regulator to discharge of that wastewater, be it to limited agricultural use, grass, watering your grass, trees, etc., or to even discharge it into the rivers. That needs to meet a certain compliance level. So that is really the reason that people start off treating wastewater. So as I said earlier, what we then said, we wanted to come out and replace these surface aerators. But not only. So in fine bubble, which is the main, let's call it the main way of water treatment today, classic fine bubble still has a lot of setbacks. In other words, it's fixed to the floor. Now, for example, the United States, the agricultural, I forget the name at the moment, but they recommend that people take out the aerators and check them once a year to see that there's not a buildup of clay and silica on it, etc. Now, no one ever does that. Why? Because once the plant operates, to shut down an operating plant is very difficult. So there is often a case where a company would have, or a municipality would have, a seasonal load on the system. Okay, and they would need because of an immediate lack of oxygen, they'd need an immediate remedy for that. So so that's one of the reasons. Now, touching specifically on your question, floating and floating and retrieval. So the floating part is that it can sit on top of the water. In other words, even if there's an operating system over there, we can still float that. Second reason is when it sits in a lagoon, right? Obviously, a lagoon doesn't have a concrete floor, and therefore it can't have anything but a surface aerator or a floating mechanism of aeration of such. And we come to resolve it, to kind of resolve that problem. We then have a retrievable, and we realized that we can also participate in the upgrade or the new build of new reactors. So, for example, the project which is sitting behind me is a new build installation in Blackmans Bay in Australia, in Tasmania. They came to us with a design requirement that they wanted to meet the projected effluent consent in the municipal plant for today, i.e. for let's call it 2025. But they wanted an ability to upgrade the plant without building new reactors or new capacity to 2040 estimated capacity. So that's where retrievable, the name retrievable, comes in. Because in other words, all we need is a crane really to come out, lift the unit up. In the picture behind me, you can actually see spaces in between where the diffusers are. New diffusers are then simply screwed into that, and we, hey presto, are able to pump more oxygen, which means more capacity. So a long way to answer a short question, but that's what we do, the benefits of floating and or retrievable fine bubble aeration systems.
And I'm wondering as well, I mean, easier maintenance, would that be another potential benefit of the way your technology works? Would that make sense? Or?
Oh yes, well, 100%. You know, I think when we talk about this, and I think I touched on that a moment ago. You know, it's recommended that maintenance is done continuously. However, you know, most plant operators will tell you that once the system is in the water operating, especially if it's fine bubble, very seldomly is maintenance done on the system unless there's a breakdown in the system. So in our situation, in our technology, it's very simple. The crane comes to site, the unit's lifted out the water, the membranes are checked, the unit is checked, right? The system is checked and it's put back in. So we're able to, you know, let's call it a plant, which is a fairly significant size, like the one sitting behind me of Blackmans Bay. We're able probably to check, test, replace, and do everything required within 24, maybe 48 hours if it's a very large plant. So pretty simple. And of course, the key part of that whole thing is live while the plant continues to operate and there's no shutdown required, which obviously has a flow through effect to the rest of the system.
Okay, and alongside the actual aeration systems themselves, you offer other bits of technology, I guess complementary ones, but so yeah. The airlift purge system, I think, is another one of yours. So perhaps you can just again outline how that works and benefits.
Yeah, so I think the airlift purge system is actually part of the aerator system. So what the airlift purge system is, if you look and you know the aerators, basically it's a tube, right? On the tube there's a membrane. Okay, the membrane is made of different materials depending on the application: EPDM, Teflon coated, silicone. We do offer a bespoke system, and we obviously tailor this to the need of the water and the chemical parameters of the water. But these things sit into deep water, and what happens is air obviously gets pumped down into them and then gets pushed out through the pipes, right, into the membrane, and through the membranes millions of little fine bubbles come out. Now, when you have condensation and or water, okay, which enter into those steel pipes, okay, it does a few things. One, it makes the air over time, this buildup of silica, or whatever it is on the membranes from within, let's call it, offers less, makes the units less efficient in terms of their capacity, and also affects the buoyancy. So what we've developed in there is like this continuous airlift purge system. So it continuously purges out any water or condensation which might come into it and pushes it out, therefore giving, increasing the benefits and improving the buoyancy as well, which leads to more efficient systems overall.
Okay, and then the final piece of the jigsaw puzzle is perhaps the diffusers themselves. So again, if you can just outline what it is you do with those and benefits.
So the diffusers really, this comes to our overall design of our unit. So we started off with a very simple, what we call a cross grid system. It was this really this pipe in the middle, and you had really crosses over it and diffusers coming off those crosses. And that is still a system that we designed. But what we then developed, we realized that not all wastewater plants are created being in a lagoon due to it being in a concrete reactor, which has a specific shape, right? It could be in even a square concrete reactor, but they've built walkways out of concrete over it. In other words, in order to get the maximum coverage, which is what we want, the units, right, need to be of different sizes and of different designs. So we've designed a whole bunch of them, from what we call grid to even a spiral one where we have 50 meters of continuous spiral going around, which has its own benefits in terms of buoyancy and in terms of efficiency. But essentially, we design a bespoke solution based on the reactor. Okay, and it's all designed for one, maximum floor coverage, and two, the requirement of the wastewater plant and what its needs are. Are its needs to treat maximum capacity? Does it have specialized needs, like, for example, a paper mill or an oil refinery, or just regular municipal effluent? And then what we do is we'll design the diffuser layout and system based on that.
Okay, and in terms of the way that people can acquire them, I guess for a lot of people, they will invest in a system, install it, and that will be that. But you also offer the flexibility of a rental option. So perhaps you can talk us through that and the type of applications where that might be of more interest to people than actually investing in the capital in a system.
Correct. So over time, what we discovered is that depends on if it's municipal and industrial. Okay, the look at capex and the capex approval process is a very long one. And people, before they spend money, a lot of money, they want to make sure that the system works and it actually meets their needs. And that's one of the reasons, by the way, it's taken us 10 years to really be on the up and up, because people in this industry are very conservative. They don't want you to touch their wastewater because by screwing it up, so to speak, let's call it the result of that is either stopping your process, your plant, or paying a fine to the regulator because your effluent isn't that. So it was a long process. So also the capex process is a fairly long and expensive process. And what we found in that is that people want to potentially test your system first. Okay, so we call it a pre-sale trial, and rental as well, but it's pre-sale trial where people can trial it for a period of time, 3 or 6 months. We bring it in, we put a blower, we put a number of units in. People are able to test it out, test the benefits. And that really has been our best sales tool, because once people actually see that the system works in their environment, in their plant, even though it's not a bespoke system, but a standardized system, they can then imagine the benefits of having a specifically bespoke design system for them. And in almost every case, right, this rental pre-sale trial has ended in a capex investment. So that's the one reason for doing that. The second reason is, and I think I alluded to this a little bit early on, but I'll maybe expand with your permission just a little bit, is that there's often an emergency oxygen situation. And I'll give you an example of that. A plant breaks down. Okay, the internal let's call it regulations within that organization of the wastewater plant dictate that if they don't meet the regulator's consent, they need to shut down the plant. Well, if they shut down the plant and it's in an industrial plant, that means potentially lost production. I'll give you a prime example. You know, the Intel, the Intel global Intel chip manufacturer, Intel, they had a plant. Their plant stopped working. They needed additional oxygen. They had two choices, because their perspective is it comes from, you know, high up, and it says we're a green company. We look at green principles, and therefore, you know, if we don't meet the consent, okay, that we required, we shut down the plant. They came to us, can you help us? We, within 24 hours, supplied them a couple of units, which went into their system, into their plant with a blower, and it allowed them to meet the consent while they sought other solutions. Once they'd rectified the solution, and the solution they used was using another plant which they had on site, they then shut down the first one, they fixed it, and came back and operate the old plant. They ended up buying 2 units from us to have installed. So when it happens again, they don't even have to come to us on a rental basis. So those are the type of solutions that we offer it for, and we're finding more and more that is a very important, you know, a very important sales tool to us. That we have these rental units available. We now have them available in the UK, we have them available in Australia, and we have available in Israel. So we have actually kits ready for clients when they want them.
Okay, and my next question, which you might just have answered there, but I was going to ask you about any customer stories you were able to share. So you give me a good example there. Are there any other ones you would like to share that highlight, you know, the work that you've done and solutions you provided for people?
So, you know, so I think Intel was obviously one, and we're very proud of that. And you know, it was a great success. I mean, I'll share 2 more short ones very quickly. One was, we did a project maybe about 6 months ago in Chile. There was a winery in Chile. They had dugout lagoons. Okay, dugout lagoons with old surface aerators. The equipment wasn't working. These lagoons, the process couldn't be stopped. They had to continue. They rarely, as an emergency, asked us to manufacture and ship, which we did. You know, shipping alone was about a month, but we got it there. We installed it in the system. You know, anyone can go to, by the way, our website and see some very cool videos of it, of the whole process of manufacturing, shipping, you know, bringing it to site, installing, putting it in the water, you know, and that was a success thing. And now we're busy designing a second phase for them for another winery that they're. So that was another success story. And I think, you know, the project which I'm sitting in front of, Blackman's Bay, it's just an example of a non-floating, of a retrievable, and that we're very proud of, because we came into a new build, and we generally are on new builds compete with fixed to the floor, which is often a little bit cheaper. But when you take into account the overall cost, right, in terms of you know, the ongoing operational efficiencies of being able to retrofit and fix things in live working things, being able to grow with capacity, like we briefly discussed earlier. So we developed these retrievable systems. You know, 4 years, I think, 4.5 years since we installed it. We have a happy customer, right? You know, every few months we touch base with them, see how they are, anything else they need, and the plant's operating fantastically. And in fact, you know, there've been a couple of newspaper articles written on, you know, written on the plant and written about the technology. So that those, I think, you know, are some examples, and those are some of the projects that we're most proud of.
Okay, and maybe just as we finish up, and while you've answered the questions, I think you've given a fairly good idea of what makes you different. But in terms of people looking for aeration solutions, it would be good to understand if you're able to give them any guidance as to, you know, what sort of technical components, if you like, and benefits. What should they expect when they're evaluating different aeration solutions? What are the things they need to look out for, beware of, whatever? Just any advice as to when people are evaluating technology.
So I think the number one thing, and a lot of people often fall on this, is they look at direct capex. Okay, and I always say to people, don't only look at capex, look at what we call totex, right? Total expenditure over the project, over the anticipated lifetime of the project. So that would include the capital expenditure, obviously, up front, It would include the operations, operations and maintenance over the time of it, and it would include the energy usage of that particular system over time. When you do an evaluation of all of that, rather than just at CapEx, you get a much better picture. Unfortunately, though, often cases, especially in the municipal world, there's a budget, and the budget looks at CapEx versus CapEx, and OpEx comes from a completely different budget, and therefore it's not of interest. But I would really encourage, even on the municipal level, municipalities to look at what we call the TOTEX, over the life expenditure of this, because I think it will save, it will save the plant, and obviously as a lead on to the people out there, a lot of money over time. So that would be the first one. The second thing is look at, and I suppose it's part of TOTEX, but it's very carefully at energy consumption, right? Not all things are equal. In other words, to put the same amount of oxygen in the water for a surface aerator, it requires roughly, well, between 3 and 4, in standard conditions, between 3 and 4 times what it costs for a fine bubble aerator, fixed to the floor or floating. So that's another, prime area to look at, is the energy. And I think lastly, just try and limit it at 3 would be to look at the operations and maintenance. The EPA in the US, the Environmental and Protection Agency, recommends checking the units, whatever they are, surface aerators or fine bubble, yearly, because the overtime fouling and the scaling create back pressure, create more energy needs, et cetera, et cetera, et cetera. But, no one looks at their, very few look at their plants and look at the operations and maintenance and look to maintain them on an annual basis. I would say even on a 5-year basis, very seldomly people do it. And I suppose these 3 things are some of the things that, Mapal is proud that we're able to add them, or we're able to add to the industry, to be able to take a look at these 3 and offer solutions to them.
Okay, I mean, that's fantastic. You've given us some brilliant insights as to what's going on at Mapal. So, Ilan, I really appreciate your time. Thank you very much indeed. Thank you.
So thanks for having me. And yeah, I encourage people, if you're interested in the area, please reach out to us. Please reach out to us to help us assist your business in designing a better wastewater solution. We do it for free, the design process. So you can step out at anything, but we're more than happy to communicate with our really tens of thousands of potential customers out there in the UK. And thank you.
Thanks again. Thank you.